Welcome back to the lab, folks. So what I have for you today is I got this, I bought this from FNIRSI off of AliExpress. As you guys know, AliExpress is my favorite shopping place these days. So what this is a component tester from FNIRSI. The newest component tester. And since I had those other component testers I've tried out before, I thought, oh, it'd be great to get one of these and see what it's like. How does it compare to the other ones? And well packed again, as usual. FNIRSI are really good about packaging. They put these in everything into these big, heavy styrofoam boxes or big cardboard boxes. Well, there it is. Looks like it's got a seal on the side here that needs to be unsealed. And we'll get into that quickly as we can. I got some components laid out here and a little story to go with everything. So let's see what's in the box. Nice box. I'm going to keep that just in case I want to give this away at some point. There's the unit itself. Oh my, and it does feel nice in the hand. That feels solid. Well, a second, we got here a little box of goodies, I guess. What do we have here? We have a USB-A to USB-C charging cable, I presume. And we have a module here. So it looks like this module here is replaceable. So that is your standard ZIF socket fixture. And this looks like it's a SMD component fixture. It occurs to me, just off the top of my head here, that you could build your own fixtures for this to suit your own needs. That would be kind of awesome. Like one to replace these three horrible leads. I've made comments about these sorts of things before, although let me get these untangled. These little grabbers seem to be of better quality than the ones that came with a couple of the other component testers that I got, notably the T7. Those ones were really bad. They were flying apart as you were using them. These ones do seem to be a little bit better, but I really don't like this arrangement. I'd rather build a fixture with three light leads permanently attached to it that come out to proper clips. But that's for a future video someday. Okay, so let's put this fixture in here. And here's the manual. It's a rather small manual. It's got at least one language first, Chinese, I guess, and then English. So I'm just going to read this a little bit and I'll come right back. I went through this thing here and it does tell you the basics of how to operate it. There's no indication on its accuracy, and that's fair enough. My idea about these items, they're not a replacement for a meter. They're for quick sorting of parts, deciding which parts need to be put in next. If I'm sitting there building a project, I got all my parts collected together, rather than using, you know, a much higher magnification magnifying glass to try and look at each resistor and see which one to go in next. I can just pop it in here, and within a couple of seconds I can find out what value that resistor is, then pop it into the circuit board. Sometimes I'll collect parts on my bench here, and rather than tidy them up right away and go and put them away, I throw them into a little box that I have on the bench, and then I'll sit down someday and I'll go through them. And so I'm not looking for them for accuracy. I just want to know if I put a 1K resistor in it, it comes up as, you know, 990 or 1K10 or something like that. That's fine. I know it's a 1K resistor, so I bin it as a 1K resistor. They're perfect for that sort of thing. So let's quickly go through here. Transistors, diodes, voltage regulator diodes, which I assume means Zehners. And it looks like it's got two ranges, to 4.5 volts and to 32 volts. FETs, SCRs, capacitors, resistors, inductors, battery up to 4.5 volts. And infrared remote control decoding. Then it just gives you the basic idea of how to put components into it. And it gives you an idea of how to update the firmware. You just download the firmware file, and in it is the application to do the upload. And you just press this button and this button at the same time, and then it comes on in update mode. And then you plug it into your computer, so Windows 11 will pick it up right away, or Windows 10 even. And then you run the application, pick the file, it's done. So let's get immediately into testing this device. Now, There's no information given about doing any kind of calibration like there is with the other ones. So I'm assuming they do that at the factory. So let's start with this resistor here. I'm going to test everything here on the Ryman first, and then compare it to what this says. And now again, like I don't expect agreement to within 0.1% or anything like that. To me, if it's, for my purposes, if it's within 5%, it's great. This is reading 9.7, 9.8 megohms. There we go. Okay, so 9.4 megohms. So it differs from this by about 400K, which is what, about 4%. That's, to me, that's fine. That's perfectly all right. Okay, this is 9.952 K ohms. So 10.08, again, it's well within 5%. You have to determine whether or not that's good for you. But for me, for what my use case is for these, that's perfectly fine. I think this is a 1 ohm resistor. 1.2. This one's off a little bit. All right, so it's not great down the low end. Okay, let's try some inductors now. Stick it in here and see what it says. You know what, I do have something else I can test them with. Hold on. Let's test this in here first. Okay, so it says it's got 10 microhenry. So here we are in inductance mode. It's coming up 9.6 microhenry. So that's pretty close. All right. Let's see the next one we have here. We have one that's, I think, is much larger. Okay, that says 1 millihenry. And it says 932 microhenry. Another nice thing about it is the value stays up there for a nice long time. I think that's a really good feature. I like that. But let's move on to some capacitors now. Okay, so it's 1019 nanofarads, or 1 microfarad if you wish. Now let's see what we get here. It's right on 1 microfarad. It's coming up with an ESR 2.45 ohms. Let's try this one here. This is your typical 0.1 UF MLCC. Let's see what it makes of this. 101 nanofarads. So that's close to what's marked on this. So this is coming up at 94.48 nanofarads. And finally, we got this little electrolytic here before I get to these ones. V loss 2%, ESR 2.33 ohms, and 11.9 microfarads. It's supposed to be at 10 microfarad, that's what's marked on it, but the percentage on this is plus or minus 20%, I believe. So let's try it over here. Let me short out the leads first. Now, I know the ESR reading on this is pretty good, and it's coming up with 6. So this has got the ESR incorrect. But as far as the microfarads go, we're within 20% anyway. Okay, let's try this. Light emitting diode here, the red one. Expect a forward voltage of about 1.7 volts. Yeah, 1.7 volts, 1.79. Reverse current 36 nanoamps. And a capacitance of 18 picofarads. That all sounds around about normal. Okay, green LED, 2.55 volts forward, 10.8 nanoamps reverse, and 20 picofarads. Let's just try a regular silicon diode here, a 1N4007. Yep, that's the sort of stuff you'd expect. 0.651 millivolts forward voltage, 9.1 nanoamps reverse, and 11 picofarads. This is a 1N60A. Forward voltage of 2.74 and a much higher reverse current of 45 nanoamps. So yeah, 5 picofarads, it's very tiny diodes, so that's what you'd expect. Okay, so far I'm liking what I see here. Like I say, it's not perfect, and I don't expect it to be. Let's try transistors. Okay, so we got an NPN transistor here. Symbol looks right. HFE of 245. So this is a 2N2222, so that looks around about right. Emitter current of 2.24 milliamps and a VBE of 6.18 millivolts. It's all around what we would expect. Okay, so it's a MOSFET. This is a 2N7000. So V threshold 2.42 volts. That's nice. Gate capacitance of 34 PF. RDS 1.9 ohms. VF 656 millivolts. All right, so it got the MOSFET right. Let's see if it gets the PNP right. This is a 2N907A, the complementary transistor to the 2N2222 that we already tested. Got the symbol right, got it as PNP, and specifications kind of do match the 2N2222. Now I got a couple of Zener diodes here. I think they use these KAA terminals down here, if I'm not mistaken. So I think if you put it up in here, it'll just measure it as a regular diode. And it is. It's measuring as an ordinary silicon diode. Now if we put it down in here, and then press the Zener test mode, press test. Okay, so this is coming up at 29.94 volts. This is a 30 volt Zener. Okay, I have this little remote control that came with my little Bluetooth speaker kit that I put together a little while ago. So let me push a button, see what it gets. It's supposed to point it down at this there. Oh, it can read it. Okay. Did it read the same each time? Yeah. Perfect. So this device has an address code of 00FF, and all the control codes read the same each time. So that works very well. Let's take this off. I usually don't like to leave those on. There we go. Well, let me sum up here. So what do I like about it? I like the way it feels in the hand. It's a very, very well-made, well-constructed device. It's got this little metal insert here for putting a lanyard on it if you wanted to do that. That's not in my use case scenario whatsoever. It works quite well generally. For normal readings like capacitance, forward voltages, whether or not it's a resistor or an inductor or capacitor, whether or not it's a NPN or MOSFET or a PNP. It can light up LEDs, it can test Zener diodes, which most of these cannot, by the way. It does all that just fine, but ESR, not so much. But what it does have is this really nice fancy little module that comes in and out. So here's the one for the surface mount devices, and you could create your own. Like you could just, I looked at the back of this thing, it's quite clear what signals are coming from where. And the back of this one here too. So this connector here has both pins 1 and 2. This connector here is pins 3, and this over here is K and A here. So you can make up your own test fixtures for it. And I think that's a really handy feature. I'm very impressed with the build quality of this. It's very nicely put together. It's nice and thin. It's compact. It's very solidly built. As far as its performance goes, it's extremely competitive with what else is on the market. And on top of that, this is extremely high build quality, which the other ones just don't have. So I think it's a very good choice. So if you wanted one of these things, you definitely won't go wrong by picking up a FNIRSI LCR-P1. I think it's going to become my favorite of all of them. I can build up some nice little test jigs for myself. Yeah, I think this is I think they have a winner here. If you're interested in getting one yourself, I'll leave a link down below. It's also a nice way to be able to update the firmware. Most of the other ones, if you want to update the firmware, you got to pull the board out of them and solder wires to them and jump through loops. And this has got a beautiful system where it's so simple, easy, and only takes a couple of minutes. It's got the same aesthetic vibe here as the DMT99, which is nice. I hope that FNIRSI continue on with that. It kind of looks nice, actually. Not that I'm into aesthetics that much, but these two kind of look really nice. They kind of built out the same philosophy as well, well constructed. So yeah, I'll give it a good thumbs up here. I think it's the, of these little component testers, it's the best one out there. So I'd like to thank you guys for coming on out today and joining me. I hope I helped you make a decision. I hope you got something out of this. And I'd also like to thank AliExpress and FNIRSI for making these great little gadgets available. They're helpful, they're useful, and they're a lot of fun to play around with as well. So we'll catch you in the next video, folks. Until then, bye-bye.